So we have an object mass m that's initially at rest, so v0 equals 0. It can move without friction in any direction in an xy plane. So there's a plane. So there's the object, here's the x, and here's the y plane. A constant net force of magnitude F is directed in the positive x direction for 1 second. So we have a force over a period of time, and that's going to bring about a change in momentum, which will bring about a change in velocity. And the change in velocity is v minus v0. And so v0 was 0, we are told, in the x direction. So we have mv. So that's going to bring about a change of momentum, and it's going to have some velocity v at the end of that. So we'll have some velocity v in this direction. Immediately thereafter, a constant force of the same magnitude is in the y direction for 1 second. So there's going to be a force in this direction for 1 second. And so since this is now at 90 degrees to it, it is going to bring about also a change in mv. Delta p will be m delta v. And so the final velocity will be the same velocity in the vertical direction as it had in the horizontal direction. So after that force has been applied, Vx and Vz will have the same magnitude, giving us a resulting velocity of this. And since Vx and Vz are the same, this is a 45-degree angle. So which one could represent the velocity of the object at the end of 3 seconds? So here is 1 second, and then the second, and there's another second later. Since there's no friction, it's going to continue moving at a constant velocity. So if we look at the velocity in the x versus time, it'll start at 0, and it'll increase to some level for 1 second, and then it will stay at that value. And the velocity in the y direction versus time is going to remain 0 for the first second that the force is acting. And at the end of the first second, it is going to experience that, and it will have a velocity like that. And so that's what's being depicted here. 1 second, 1 second, and 2 seconds. And then they're asking what's happening at 3, and at 3 seconds, they both have that same velocity. So we want to know which one, and we're told that the scales on the x and y axes are equal. And this may be the thing that makes this question difficult. So the graphs are exaggerated. So the scales being equal means this is saying the y direction and the x direction. This is saying it's only moving in the x direction. Well, that's false. We can see that. In choice B, we can see that it's 2 units in the x and 1 unit in the y. And we should be looking for a 45 degree. Now here we see 1.5 unit and 1.5 unit. So it looks like C is our answer. We'll continue to D, and we notice 1 unit, 1 3/4 units. And E, there's no motion in the x direction. So we're left with choice C.